Wow. Well, at least we hope so.
It's actually good. Shout out Twilight.
Okay. That's a weird thing for us to talk about. Okay, do we have any greatest common factors that we can pull out? Greatest common factors. Okay, so the GCF here is 10x. Thank you very much. Not only do they have a 10 in common, but they also have an x. So, I suggest you pull out 10x and tell me what's left. X squared, good call. Folks, when we say taking out that factor, we are dividing both of those things by 10x. Minus 1, thank you very much. The question I have for you now, is there more factoring that I can do? Will this break apart even further? It will. Okay, go. Factor it. And so what is your final factor? So that's part of it. Except you're missing something from what we did in the beginning. Notice how I have 3 factors in green there. As I do realize that we're using that division, we'll write it in factor form.
Crying out loud. Jesus was.
He was, but he did with me.
He had manners. Jesus had manners that you guys don't have. Get your manners up. Relax, I see you. Get your manners up like Jesus.
Difference of perfect squares. Take the square root of each. Okay, so it's a difference of perfect squares. What do we do for a difference of perfect squares? So what do we do for the difference of perfect squares? Don't we take square roots?
Yes.
So that would be x and x. 1 and 1. Now what? Does it matter where I put them? No, it does not. As long as you have one of each. Now, in this particular question, there's a word that we haven't talked about, and that word is multiplicity. It says, state the multiplicity of multiple zeros. Now, it should say of all zeros. Let's just get rid of that. Once you understand the definition of multiplicity, that sounds a little misleading. Okay, now, what's our definition of multiplicity? Well, I will. Okay, it's the number of times a factor occurs. Why did I misspell something? Sorry, as his commentary must have been funny to write that down. Okay, so this is my term multiplicity. How many times do you see 10x here? You see it one time. How many times do you see x minus 1 here? 1. How many times do you see x plus 1 here? 1. So, ironically, the exponent is the multiplicity. Right there. Hey, look, we found the multiplicities. Right there, right there, right there. Which one of these answer choices should I be choosing? We are going to be dealing with A. Because every single zero has a multiplicity of 1. Now, can you tell me what those zeros are? If you do not know, then I suggest you set each one of the factors to 0 and solve them. Okay, so I agree with you here on 1. Yes, that's good. And I agree with you on negative 1. Yeah, that one's a 0. If you divide by 10, you still get 0. Does it matter in what order I put them? I'm just asking, does it matter if I put 0, 1, negative 1, 0, negative 1, 1, 1, 0, negative 1? Does it matter? I would say no, because all of them have the same multiplicity. Who cares what order we put them in? As long as we have them all. Any questions on this? Factoring, finding zeros, identifying their multiplicities. Okay, move to question 10. Just to kind of organize my information, we're gonna answer the question of what the zeros are and their multiplicities. All right? Can you look over here and tell me what either one of the zeros are? Four and 1. Okay, I agree with you. So we've got a 4 and we've got a 1. I have specifically drawn the arrows coming from the factors. Now the next thing I'm going to write in purple, I do not want you to write this down, but I do want you to pay attention to it, which means don't talk over the top of me, as some are in the habit of doing. So don't write this down, but I do want you to pay attention to what I am writing, so that you can help me analyze this. This is really what we're dealing with, folks. Why did I write out the x minus 4 4 different times? Because that's the exponent. So what is the multiplicity of the 0, 4? How many times does it occur as a factor? 4 different times. How many times does the x minus 1 occur as a factor? Only 1 time. Now, why am I making a big deal and drawing all these arrows and choosing different colors? Because I do not want you to say to yourself, oh, if I know the zeros, then I automatically know the multiplicities, and I should just copy those down. Wrong. It just so happens in this example that they're identical. So, make another one. Okay, and then we'll come back to finish this question. So, I don't care whether you use space at the bottom of the page. I'm using the space from the previous page, but somewhere you need to have this made-up example in your notes. And we'll make a little table here. So take a few seconds here and identify wherever you're putting this problem. Identify in your charts what the zeros are and the multiplicities are that go with it. Make sure you copy down the actual equation so that you know where that information came from. Okay, so what did we get from x plus 2? Negative 2. How many times did it occur as a factor? 9 times. So how about x minus 3? 3. How many times did it occur as a factor? 4. Okay. From x minus 5. 5. How many times did it occur as a factor? 7. What do 9, 4, and 7 add up to? What do 9, 4, and 7 add up to? So, folks, this is a 20th degree polynomial. A 20th degree polynomial. What I'm hoping you understand from that is this. The degree, or I should say, the degree can be found by adding the what? The multiplicities, which are the exponents. So you're right. Nice. Good conclusion. Okay, now, to finish out question 10, it said this. The distinct zeros are, well, you and I decided that 1 and 4 were the two x-intercepts that we found on question 10. But then it says this. The multiplicity of the repeated zero. Now, folks, they are asking me for only the repeated zero. You had x minus 4 to the 4th. Sorry, it's bad looking 4. My apologies to all the 4s. Okay, and x minus 1. Which one of those was the repeated zero? Right, that was over here. So what is the multiplicity of that one only? 4. When you look at the question, it's only asking me to identify the one that gets repeated more than once. Yes, question. That one right there? Okay, so which one of those zeros is repeated more than once? All of them. So, if this were the example, I would expect you to write down every single one of them. Now, so the example that they chose only had one that repeated more than one time. In my example, everything repeats. So, I would say the multiplicity. I'd have to have a chart like this for that question because every single zero got repeated more than once. So I really couldn't boil it down to one answer. I'd have to say every single one of them like you suggested. Okay, but that's not what they asked for. It just asked for the multiplicity of that one only. So if I was up here on this question, I could say the multiplicity of negative 2 is, and you could say 9. Okay. Okay, folks. Why are we cutting little squares out of the corners? We're cutting those squares out of the corners so that we can fold this up. We really want to fold up the edges and make a tray. A three-dimensional tray is what we want to make. If we cut those squares out of the corners, then we can fold up those edges and make this particular shape. We're starting off with 24 inches, but when we cut it, we get this. Just like this piece of copper. We're going to cut squares out of the corners. Then we're going to bend the edges up to make this little tray. If this were 24 inches long, and we took an X off of this end and an X off of this end, what would you call the new length? Perfect. 24 take away 2x. That would be what we call the new length right there. Okay. What would you call the new width? 18 take away 2x. So that would be this side. Now, look at the picture, think about it, and tell me what you think the height of the box is.
Are you kidding? At least we're not doing bad decisions.
I don't think it's 2x, because remember, if I cut x out of the corner and then I fold it up, the width of that cut is now my height of my box. Okay, several of you told me the correct answer was x. Remember, when you cut that square out of the corner, that dimension becomes the height of the box. Now, how did we find the volume of a rectangular solid back in geometry class? Length times width times what? Times height, right? Length times width times height. No, we didn't have to do any division on that. Unless, of course, let's see, if you were dealing with a pyramid, then you would have to do some division. Like if you had a square pyramid, we would divide by 3. But we're not dealing with any kind of pyramid, we're just dealing with a rectangular solid. So it's just basic length times width times height. Okay, now, if I look at part B, it's asking me to write the volume as a function. And then what does it say here that's really making me happy? Factored form only. So they don't expect me to multiply all this stuff together and get it into standard form. They just want it in factored form. So go write it in factored form. because I was expecting them to ask for standard form. They did not. They asked for factored form, so that does make it easier for me. Okay, lots of good answers around the room. I appreciate your work on that. Length times width times height. Okay, that's what we call the factored. Now the next part probably won't be test worthy. C and D I probably won't ask you to do, but let's kind of talk through it so it makes a lot of sense here. What do you get when you multiply? What do you get when you multiply x times negative 2x times negative 2x? X times negative 2x times negative 2x. This would be called the leading term of our polynomial. What is x times negative 2x times negative 2x? I got to vote for 4x to the third. Do you agree or disagree? Is that 4x to the third?
I agree.
Okay, so we got several people agreeing it's positive 4x to the third. You are right. Okay, positive 4x to the third. Last week, we talked about end behavior of polynomial functions. End behavior, we used words like up and down. When we see that this is a positive 4, what do we know about the right end behavior? Which word would you use, up or down? That means the right end behavior has to be up, because it was a positive 4. Then we look at the degree, and since it is an odd number, we know that the left is opposite of the right. Okay, use that information to answer part C. Use that information to answer part C. Find the graph that fits the correct end behavior. Left opposite. Not really sure which part you're talking about. Oh, yes. That's going in today. It should be actually being fixed right now, actually. So, we'll find out. But it should be an easy fix. Alright, so if you know that the right end behavior is up, you can immediately get rid of A and D. Okay? And then when you know that the left end behavior is down, that really kind of knocks out choice B right there. The only one that had the correct end behavior was right there. Now, I need you to understand or look at this picture. So we have x and we have y. What does x represent in this? Isn't this the amount that we cut out of the corners? So this would be the amount removed. Y represented the volume of the box. Can you look at this picture and tell me what doesn't even make sense? Only part of this box makes sense, or a part of this graph. Okay, anything with a negative in it does not make sense. So that whole side of the graph is ridiculous. And anything down here in this quadrant is ridiculous. Quadrant 1 is the only one that makes sense. Now, it even goes further than that. The only part of the graph that really makes sense is this green portion right here. Okay. I'm going to ask you this question. Where would you find the maximum volume on that green section? At the top of that little hill, right? You're never going to find it unless you have a graphic calculator. Desmos.com or calculus. So I'm going to say we know Desmos.com. Right now, I'm not going to ask you this on the test, but I do want you to look at the graph and see if you can help me understand it. Okay? I'm not going to have you doing this. Now you'll notice that I graphed 24 minus 2x times 18 minus 2x times x. There's the picture. The part of the graph we're interested in is in that little hill. I even highlighted the point that's at the top. Can you tell me, what am I supposed to tell my worker? This is my business. We're designing this tray to be sold, and I need to be able to figure out what to tell my worker. How much should you cut out of the corners so that we get the maximum volume? Can you tell me how much we should cut out of the corners? So I have had people today tell me that we should cut 654.977 inches out of each corner. Yeah, the width of this thing is 18. How do you cut 654 inches out of something that's only 18 inches long? Plus, you got to cut out 2 of them. One from each corner. So I was like, I don't think that makes any sense. How much? How much should we cut out of the corner? I heard it over here somewhere. 3.394. I should instruct my employee to cut out 3.394 inches from each corner. In that case, what volume will be created? Come on, don't stare. Think. No, not at the right thing. 654.977 cubic inches of volume. No, I will not ask you to do that on a test. What will I ask you to do on a test? Probably A and B for this particular question. Okay? I might make C extra credit. Okay? So the maximum volume is 654.977 and is created when x equals 3.394 inches. But we would only know that information if we had technology or calculus. So we'll go with the technology. Okay, question 12. Any GCFs that I can pull out of there? Okay, 5x, great suggestion. I'm going to add one more thing to that suggestion. Let's make it a negative 5x. Well, there's a reason why I'm going to do that, because what's left over in these parentheses, I really want that first term to have a positive. So if I pull out the negative, my life will be a lot happier. If you divide everything by negative 5x, what will I be left with? Come on, take out that negative 5x. What's x squared? Good first term. Close. Plus x, thank you. And a minus 12. Okay, so the next question I have for you is, can it be factored further? Go! Got this question and one more to do today. The negative 5x first and then factoring the rest. So what multiplies together to give me negative 12? That must mean one's a plus and one's a minus, but adds up to positive 1. Does it matter where the 4 and the 3 go? Alright, so which one's the positive? 4. Is this all they asked me to do? That's it. There's nothing more to that question. They said, write the function in factored form. Hey, we did it. Okay, question 13. Same thing. But they ask a little bit more in this question. So, what's the GCF? What are we pulling out? 8x. Good. Pull out the 8x. Go. It is x squared minus what? It's not minus nothing. Minus 1. Can that be factored further? Okay, then do it. Factor it further. It can be factored further. Thank you very much. That was close. That was close. Okay, so we should have gotten x plus 1, x minus 1. Now, I still got a minute and a half, so listen. Don't interrupt, listen, okay? This question doesn't just ask me to factor it. What else does it ask me to find? I need the zeros. What are the zeros? 1, yeah, there's a 1 right there. We got a negative 1 right there. Come on, what does 8x turn into? 0 itself. How many times do those factors occur? Only one time for each one of them. So, is it going to be A, B, C, or D? B. The numbers 0, 1, and negative 1, not in any particular order, all have multiplicity 1. Okay? Thank you very much.